What's a binomial? What does the prefix bi mean? 2. So 2 what? So binomials in this case are 2-term expressions. So when we're multiplying binomials, as in more than one, we have two-term expressions. All right. When that happens, you could use something called the FOIL method, which stands for first, outer, inner, last. And that means that, and here's an example with like letters instead of numbers, but these letters could be any numbers, where you multiply the first 2 numbers in each parentheses, in each expression, where you multiply the outer 2 numbers. So like A times B, we get AB. The inner 2 numbers, B times C, we get BC. And the last 2 numbers, B times B, we get BB. And you do that, combine any like terms if you can, and then that's one way of multiplying it. So let's try that. So FOIL, first we multiply what 2 numbers or what 2 terms? X and X. So it's the first thing in each parentheses. What's X times X? Good. Outer numbers. So the outer number of each parentheses. X times 4 is what? Table 3, what's X times 4? Don't overthink it. So, table 4. Table 5. X times 4, what's the question? What is it? Don't overthink it. What is it? What operation is implied when the numbers are like squished together? Multiplication. So, I mean, the coefficient in front of the X is 1. 1 times 4 is 4. And then the X is still there. It doesn't magically go away. Now multiply the inner terms. So, table 3. What? So my inner terms are these 2. 2 times X. What's 2 times X? Good. Table 4, multiply the last term. So last term in each parentheses is 2 and 4. What do you get? Good. And in this one, they all happen to be positive, but just remember if one of them were negative or if they were both negative, make sure you know your rules. All right, now is this fully simplified? No. Is there any like terms that I could combine? Good. And normally it's the 2 in the middle, at least when it's a binomial, that you have to combine. So x squared, what's 4x plus 2x? And then the plus 8. So then that's my final answer. Questions, comments, concerns? Can I have you guys try the example 2? That's like slightly different, but I think you guys can get it. Okay, so try that. I'll give you about a minute using the FOIL method, and then I'll show you another method that's confusing. So table 6, what are my, like when they say FOIL, like first, what are they wanting you to multiply together? So, yeah, so you got it right, and then I don't know what you said after that, but they want you to multiply the 2x times the x first. Okay, so multiply those 2 first. What's 2x times x? Close. Squared. All right, the only way you would say 2x is if I multiplied by 1. Okay, but No, it's 2x times x. Don't forget your product rule. Rewrite it over here if you need to. But when you have the same base, so like x to the a times x to the b for the variables, what do you do with the exponents? You add them. So it's x to the first times x to the first. 1 plus 1 gives me x to the second. Okay, so that's the first. Now the outer numbers, table 7, what are my outer numbers in this problem? Right, don't overthink it, use the visual that's over here if you need to. So this one literally goes first, outer, inner, last. So the outer numbers are literally like on the outside of the problem. So table 7, what two numbers am I multiplying together next? What two numbers am I multiplying together next?
1, 5.
No, that would be my last numbers. Right now we're on outer. So 2x is one of them. What's the other outer number?
5.
-5. Good. Table 8, what's 2x times -5? -10x. Good. Table 2. So we did the outer. Now we're on the inner. What are my inner numbers in this problem? Positive 1 and x. Multiply them together, class. We get just 1x in this one, because the one didn't have an exponent. Or a variable, I mean. Table 3. What are my last numbers in this problem? 1 and -5. So we multiply those together. What's 1 times -5, class? -5. Now, are we done? Is this fully simplified? No, I could combine some like terms. What could I combine? Good. What's -10 plus 1? Good. And then the x, yeah. So 2x squared minus 9x minus 5 is this answer, using the FOIL method. Now, if that's not something you like, here, I'm going to show you another one, which I think I like better the other way that I'm about to show you, because it works for the next thing too. So I just call it double distributing. I don't know if that's like a real term that people use, but it's really what you're doing. Okay, so if I have one parentheses times another, I need to take that first set of parentheses and distribute the first term to the second set of parentheses. And then I need to go back and distribute the second term. And literally what that ends up doing is the FOIL method. It ends up doing the first two terms together, the outer terms, the inner terms, the last terms. But this way, I just feel like works better, and kids know it better too, at least in my experience. So distribute the y first. What's y times y, class? Y squared, good. What's y times 1? Good. So 1y to the first power. Or just y. And then distribute now the 8. What's 8 times y? 8 what? 8y, and then 8 times 1. 8. So that's following the arrows, distributing the entire first parentheses to the entire second parentheses, and it's the same process. Do we have any like terms? Yep, we have 2y to the first power, so combine these. What's y plus 8y? Good, bring everything else down. And usually when you do it this way, it's always in standard form. Okay, but this one does say in the instructions, make sure your answers are. The questions on that? All right, this time try it with the double distributing. So try it with this one down here. Try 5. And try it with the double distributing, and then after that, I'll let you use whatever method you want, as long as it gets you to the right answer. So I'll give you like 1 minute. Can't remember where we left off, so I'll just start with table 4. So table 4. And this time I asked you guys to double distribute. So first distribute that 4x to both terms in the second parentheses. What do you get when you distribute? Same 4x plus what? Okay, so class, examine that, see if you agree or disagree. Miss Medina. So what are some good parts about that? Can someone tell me something good about it? No, nothing. Nothing's good about it. So, okay, so you're telling me something wrong with it. So is the 4x supposed to be squared? Okay, yes. Is the 12x good? Okay, so that would be like a good part of that. That's okay, we'll try that another. But yeah, so 4x times x, remember to apply the product rule. All right, 4 times the coefficient of 1 is just 4, but x times x. So x to the first times x to the first, you add the exponent. So 1 plus 1 is 2. All right, but otherwise, good. Just that one little thing that has to be hit. All right, next, don't forget to distribute now the -7. So table 5, what do you get from distributing the -7? So distribute the -7 just like you would if it was like a smaller problem. It was -7 times x. -7x, and then -7 times 3. Positive or negative? Negative. Because remember, you have to keep the sign that's in front of each term. So it's -7 times both of these, which ends up making it negative. Okay, so good. Then table 6, am I finished? What do I have to do next? Okay, good. What is 12 minus 7? And is it positive or negative? So put a plus in front of it and then bring down everything else that was there. Okay, so we combine the 2 middle terms, which is something you would usually have to do when it's a binomial times a binomial. Good, any questions? Do you remember our rules with the negative numbers? Okay, so show me that you know your rules with negative numbers. This time you can use whatever method you want. I'll have you try 4 and 6 then. And use either FOIL or double distribute, whatever you like that.
Yeah. Hayden? After Zen, yes. And guys, when it gets to 11:55, no one's going anymore. So that probably takes up the rest of the class. So stop asking me about the restroom. You're not supposed to go in the last 10 minutes or the first 10 minutes.
You guys just came from lunch. All right, so now when I call on your table, give me the whole answer if you can. So let's see. Table 7, what'd you get for number 4? So Jackson, Jessica, Ashley, don't just ignore me. What's your answer for number 4?
X squared minus 2x. Oh, I got one.
Okay. Ashley at that table? Jessica? Okay, well, I'm gonna come back to you guys. So 4 is incomplete right now. But you guys need to figure it out. I gave you guys time to work on it. You have like all these like, notes and examples. No one asked me questions. So like, I don't know what we were doing for the past few minutes. Table 8. What'd you get for number 6? Okay, can you look at it now and do it? So then what's the first step? Table 8. Are we, when we distribute class, do we add? We multiply. So we multiply the n and the 5n. What do we get? Okay, good. Next. Good. What do we get? Good. Want to keep going? Okay, and then what do I do? Which gives me. Good, and then the last step. Which gives me. Close. Negative times the negative class is a positive. All right, but otherwise very good. And then in addition to that, you want to make sure there's no like terms. So the n squared doesn't have a like term. Does the negative 4n have a like term, class? What's negative 4n minus 5n? Negative 9n, and then the 4, there's only one constant. There's nothing else to combine it with. All right. Like, it's fine if I even have wrong answers, because usually we can learn something from the wrong answers. But like the not saying anything kind of drives me nuts, because it's like, how can I help you if you don't even say anything? All right, so table 7, what do we have now after having some more time to look at it? So x squared, and then what? Negative 4. Is that it? All right, class, what do we think of this one? Why did the middle terms go away? They canceled each other out. So x squared is double distribute. So x times x is x squared. X times negative 2 is negative 2x. Now distribute that other 2 that's there from the first parentheses. 2 times x is 2x, and 2 times negative 2 is negative 4. Combine like terms. Usually when it's a binomial times a binomial, usually it's the middle 2. What's negative 2 plus 2? Good. What's 0 times x? What's anything times 0? 0. So that's why really those middle 2 terms cancel out. And that's why this is all we're left with. So good, any questions? All right, we're gonna move on from there. Luckily, this next part is not that different, so look on the back side now. Look at this part. So now it's a binomial times a trinomial. Bi, the prefix for bi means, and the prefix for tri means. So we have a 2-term times a 3-term. But really now, at this point, you should be able to do it like whether it's a 1-term times a 5-term, a 3-term times a 5-term. Because all you really have to make sure that you're doing is that you're distributing the entire first parentheses to the entire second parentheses. So I'm going to distribute the x. Now I just have to do it to 3 different terms. And then I need to distribute that 4. So in this one, there's no like FOIL method. There's no like cute acronym we could use. But that's why I say like the double distributing works for all of them. So in this one, x times x squared is good. X times 3x is 3x squared, and x times -6 is -6x. Anyone confused on how we got that? Right, all we're doing is applying stuff we've done before, like the product rule, multiplying the coefficients, same thing, and all that stuff. All right, now distribute the 4. What's 4 times x squared? 4x squared. Table 3, 4 times 3x. Good. Table 4, 4 times -6. -24, good. Feel free to use a calculator, there's nothing wrong with doing that. But yeah, so we get this really long thing. But we have to make sure that our final answers are simplified and in standard form. My suggestion is start with like, because you know, if you remember standard form, that's A, B, C order. And then if we have multiple of the same letter, then it's higher exponent first. All right, so in this one, all we have are x's. What is the higher exponent on the x? So then see if the x cubed has any like terms. Are there any other x cubed? So then rewrite it. Then move on to the next one. Cross them off if you need to, but like move on to the next highest. What's the next highest exponent on the x? So an x squared, are there any other x squareds? What is it? So what's 3x squared plus 4x squared? Combine those, and then once you've done that, you can even cross them out if you want to, because we're writing them in standard form. Next higher exponent on the x would be, and is there another x to the first power? -6x plus 12x is a positive 6x, so put plus 6x. So keep the sign that's in front of each term because that counts for when you're combining. -6 plus 12 is +6. And then we're done with those. All that's left is a -24. So there's nothing else to combine it with. But if I did have more constants, I would combine it with a constant. And then that's it. That's our answer, fully simplified and in standard form. Questions on that? All right, so then I'm going to give you some to try. try 20 actually. With the negatives, I know we love those. So you try 20. Work with your groups, don't be shy, collaborate with each other, make sure we're all on the same page. And we'll hit our cards later. Okay, I erased part of 19 just so that we could have more space for 20, okay? How do you go about solving these? What do I tell you to do? Good, and because there's essentially two terms outside, you have to make sure you distribute both of those terms. But really, like, however many terms are in the first parentheses, you distribute to the second one. So maybe I should do this a different color. So first start by distributing the k. What's k times k squared? K cubed. Table 2, what's k times negative k? Negative k cubed. Squared, good, because k times negative k, so 1 times negative 1 gives me the negative. K times k is k squared. And then k times negative 8, table 3 was k times negative 8. Okay, great. So we distributed the k. What do I distribute next, table 4? The negative 5. Don't forget to keep the sign that's in front of each term. If you just distribute a 5, well, then all your signs will be wrong. So negative 5 times k squared, table 5 is what? Negative 5 times k squared. Well, does the negative 5 have a variable? So then we need to worry about the product rule. Isabella, do you want to help him out? Negative 5 times k squared. Okay, class. Negative 5 times k squared. Right, that's it. Don't overthink it. Negative 5 times the coefficient, which if it's not written is 1, is negative 5, and then there's no other variable, but it doesn't just go away, it's still there. So, and that's a negative 5 k squared. Table 6. Negative 5 times negative k. I think you're one step ahead, maybe. Negative 5 times the negative k. Oh. Is it gonna be negative 5k? Class? What's a negative times a negative? So it should be a positive 5k. And then negative 5 times negative 8, table 7. Negative 5 times negative 8. Good, so then you put plus 40. All right, and then once you've done that, the distributing, usually after distributing, you have to combine like terms anyway. So then now do that. Table 8. Is there a like term for the k cubed? So then you just rewrite it. Table 2, and then I'm going to cross it out so I don't get confused. Table 2, do I have a like term for the negative k squared? What do I get when I combine those? Good. So remember, combining, you're adding the coefficients. So I have a negative 1 plus a negative 5. Negative 6. I'm going to leave the variable part alone. Table 3, does the K to the first have a like term. Good, what's negative 8K plus 5K? How about someone other than Elise, because she's been carrying your guys' table the day? So table 3, negative 8K plus 5K. Negative 8 plus 5. No, try again. Feel free to use a calculator if you need to. Table 4, how about you help out? Negative 8K plus 5K. Negative 3K. Okay, so negative 8 plus 5, that's like owing someone $8 and then paying back $5. You still owe the $3. And then lastly, there's nothing else to combine with the 40, so you just add it on to your answer. So questions? All right. I'm gonna give you the rest of the class time to practice. And it's just evens or odds. So maybe write that at the top, otherwise you're gonna end up doing all of them and then get upset. All right, so your choice. Either do 2, 4, 6, 8, 10, 12, 14, 15, 18, 20, 22, and 24. Or do 1, 3, 5, 7, 9, 11, 13, 15, 17, and all of the rest of the odds. No, you cannot just do half. All right, they do get harder as you work down the page. You need to be able to do some of the harder ones. That's why I'm only making you do the evens or odds. All right, tomorrow I'll have the key printed and taped to the wall so you can check your answers. But you have like about 10 solid minutes to get as much done as you can. And please, for the love, ask questions. All right, that is all.